Hey everybody. So, since I didn't actually get to do this designing circuits example in class today, I thought I would take just a few minutes and set this up and go through it with you. That way, when you go to do the homework, you'll be all set. I don't think this should take any more than 8 minutes. Let's see if we can do it. So here's an example. Designing circuits. Let's say that you are given a 12-volt car battery. We're going to ignore any internal resistance in the car battery, and that's fair. We have a laptop. Its battery runs at 6 volts and has a power consumption of 36 watts. We have a light, 3 volts, 12 watts. We have an RV fridge. I've always wanted an RV, but they run off a 12-volt power supply. This particular model has a power of 60 watts. And you also have as many variable resistors as you need. Now, if you can't find a variable resistor in the apocalypse, you know you could just use a length of wire and figure out the resistance of that wire and then determine how much wire you would need to create that resistance. All right, so how do we hook up a circuit so that all three of these things could be powered simultaneously off of that car battery? All right, let's look. So I know that I need some sort of circuit. Where could I start? I think before I can do too much, I need to find out how much current each device will draw. And I can use that using P equals IV. So if I use that power is current times voltage, then the current is simply power divided by the voltage. So at 6 volts, we'd have 36 watts of power. That's going to be equal to, yeah, you got it, 6 amps. Now for my light, current is power divided by voltage. I'm just going to say that that's going to be 4 amps. And for the RV fridge, 60 divided by 12 is going to be 5 amps. So it looks like I have all different currents in this circuit. If they're all different currents, then I can't put them in series with each other, not unless something else is going on. So I think that the best, cleanest approach would be to put these in parallel with each other. Now I'm going to do this. Boom, boom. So let's go ahead and do that. So I'm going to start with, I have a car battery, 12 volts. And the order that I put these does not matter. I sometimes like to think of if I put the resistor first, I know it will drop a certain amount before it gets to my laptop. Now I'm going to call that a computer. So we'll go with C. Okay. And then down to 0. Now, if I hook up another circuit that's going to have, let's say this time I put the light first and then the resistor, amazingly, it doesn't matter that order. In that branch, the electricity is going to drop over the light, and the variable resistor. Doesn't matter the order. And lastly, I have an RV fridge. Now that RV fridge has 12 volts, or needs 12 volts, and I have a 12-volt power supply. So you know what? I think I just need the fridge to be hooked up in parallel. Okay. Now, I look at this, and I already calculated that the computer needs 6 amps to flow through it, and it has a 6-volt drop. Now, in that loop, I need to have a total of 12 volts. Yes, and I know some of you already see the numbers and how it's going to play out. That's awesome. But if I go with loop number 1, I'll label that one number 1. I would say the sum of the volts around that loop is 0. So plus 12 minus the voltage across the resistor minus the voltage across the computer, which I already, oh man, is it just 6? Is it that easy? The answer is yes, it is. It has a 6-volt drop, and I need it to have a current of 6 amps. So the resistance that I would use, since V equals IR, 6 divided by 6 gives me a resistance of 1 ohm. So R1 is going to be 6 ohms. Let's look at R2. So to find R2, I'm going to play the same game, but this time we'll look at this loop. Maybe at this time, you go ahead and do this on your own. You can do that. Yeah, go ahead. I'm giving you a head start. When I look at loop number 2, since that light is going to have a voltage drop of 3 volts across it, I could go ahead and use my loop rule the way I wrote it out, or I could just think about it. I'm going to have plus 12 minus 3 minus the voltage drop across the resistor. Yeah, so it's obviously going to be 9 volts. Now the current that I need to flow through that is going to be 4 amps. So to find the resistance, voltage divided by current, or 9 divided by 4, or a resistance of 2.25 ohms. And there it is. We just designed a circuit that would work, and we could power different devices off of a 12-volt battery. That's pretty good. Yeah? Now, if you don't feel comfortable about this because you're not sure about how the 4 amps goes through, you could always double check this by redrawing the circuit, not as a computer, but just as another resistor. And I think what you'll find is that it works. All right? But I'm not going to take up any more of your time. This was in case you were feeling uncertain about how to approach these problems. So in designing a circuit, it's nothing more than utilizing the power formula, the loop rule, Ohm's law, junction rule, everything else. All right? Thanks.